Hello, welcome to Anybody Can Learn. Today we will learn gradient descent. Suppose you want to predict the house price. For example, if the size of the house is 1000 square feet and its actual value is 40 lakhs rupees, or if the size of the house is 1200 square feet and its actual price is 48 lakhs rupees, or if the house size is 1500 square feet and its actual price is 60 lakhs rupees, or if the house size is 1800 square feet and its actual price is 72 lakhs rupees, then we want to predict the price of the house whose size is 1000 square hundred feet. Our goal is to build a model that can predict the price of a new house. We need to find the predicted price. This is a primary job of linear regression. The simplest linear regression model is based on basic mathematical formula of y hat is equal to wx, where y hat is the predicted value, w represents the weight, and x represents the input feature. Suppose we assume a weight is equal to w is equal to 2. Then mathematical model becomes y hat is equal to 2 into x, where 2 is a w. Why do we need a gradient descent? Suppose the actual relationship in the data is y is equal to phi x, where phi is a w. But our model starts with an assumed weight of w is equal to 2. The model is entirely wrong because the weight is incorrect. The main questions become how we change the weight from 2 to a better value. The correct answer to this problem is gradient descent. Imagine you are standing on the top of the mountain and your goal is to reach to the lowest point of the valley. You cannot see the whole mountain because it is dark. You feel the slope around you. You take one step downhill and stop. Again you feel the slope and take another step downhill. You repeat this process until you reach the bottom. This is exactly how gradient descent works. Imagine the mountain is our loss function and height is error or loss, and the lower point is the minimum loss the best model has. Walking downhill means updating the weight. What is error? The model makes predictions and sometimes they are wrong. The difference between the actual value and the predicted value is called the error. So error is equal to y minus y hat, where y is a actual value and y hat is predicted value. Let us look some simple example. The actual value is y is equal to 10 and the predicted value y hat is equal to 8. Then error is calculated by 10 minus 8 is equal to 2. Therefore error is 2. What is a loss function? The loss function measures exactly how bad the model is. For linear regression, we usually use the sum of square error, that is SSE. L of W is equal to summation of the actual value minus predicted value square. So yi is the actual value and y hat is the predicted value. We will square their difference and add all such differences. So our final goal is to make this loss as small as possible. Now visualize the loss. Imagine plotting the loss against the weight of the graph. A typical linear regression loss looks like a bowl-shaped curve. The lowest point represents the best weight and the loss is the smallest at this exact point. What is gradient? The gradient tells us how steep the loss function is. It shows in which direction the loss is increasing most rapidly. A positive gradient means the loss increases as the weight increases, and a negative gradient means the loss decreases as the weight increases. The gradient acts like an arrow pointing the uphill. To reduce the loss, gradient descent must move in the opposite direction. What is the learning rate? The learning rate is represented by the symbol eta. It controls how big each update step is during the process. If eta is very small, we experience very slow learning. If eta is very large, the model may overshoot the minimum point. Let us look at an example for the weight update. Old weight is 10, its gradient is 4 and learning rate is 0.5. Then we will calculate the updated weight as W new is equal to 10 minus 0.4 0.5 multiplied by 4. This will give as a 8. So weight changes successfully from 10 to 8. The core formula for updating the weight is very important. W new is equal to W old minus eta times gradient. W new is the updated weight and W old is the current weight. Suppose the gradient is positive, that means moving to the right increases the loss. So to reduce the loss, we must move down left. Subtracting the gradient automatically moves us downhill toward the minimum. We need a specific formula to find the gradient for our model. So that formula is 2 times x transpose x into W minus 2 times x transpose of y. So the gradient is calculated by this formula of 2 multiplied by x transpose x multiplied by W minus 2 multiplied by x transpose multiplied by y. This exact formula tells us how the loss changes with respect to the weight. It is calculated directly using the training data features and actual value. X is a training data feature and y is the actual value. Combining the update rule and the gradient gives the final equation. W superscript 1 is equal to W superscript 0 minus eta times 2 multiplied by x transpose x multiplied by W superscript 0 minus 2 times x transpose multiplied by y. W superscript 0 represents the initial weight before any changes. W superscript 1 represents weight after first update. The superscript indicates the iteration number. They are absolutely not mathematical powers. For example, if the initial weight start at W superscript 0 is 2 and after one update it becomes W superscript 1 is equal to 5 and after another update it becomes W superscript 2 is equal to 4.8 and after another update it becomes W superscript 3 is 4.98 and eventually weight settles perfectly at W is equal to 5. The weight gradually approaches to the exact value that minimizes the loss. So the complete algorithm for the gradient descent is: initialize the weight W, make the prediction using the current weight, then compute the loss to see how bad the predictions are. Again compute the gradient using the correct formula and then update the weight using W new is equal to W old minus eta times gradient. Repeat the step from 2 to 5, that is making the prediction, computing the loss, then computing the gradient and then updating the weight. Repeat these steps again until the loss stops decreasing significantly. Let us summarize the flow. Training data. Initially choose the weight, that is W superscript 0, and then make prediction y hat. Then calculate the error y minus y hat, that is actual value minus the predicted value. Then calculate the loss. Then calculate the gradient. Then update the weight, that is W new is equal to W old minus eta times gradients. Repeat the step of making prediction to updating the weight until the loss is minimum. And finally train the model. Thank you.